Good morning, everybody, and welcome to the fifth session of Janaganit. This program, Janaganit, is conducted by a group of organizations which are mentioned here on the chart behind me. And all of us believe that everybody can do mathematics, everybody. But for doing mathematics and mastering mathematics, understanding is very important. And for understanding, doing is very important. Making, constructing. Now, in all these sessions of Janaganit, if you are only listening to what we are saying, that is not sufficient, because you cannot learn mathematics by listening to a lecture. Doing is very important. And therefore, it's important that you must have the materials that we had sent a list about in the communication. Let me communicate to you again the materials that you must have with you today, because you will be doing mathematics. And if you don't have those materials, we will take a break of 1 minute while you collect those materials. Those materials are easily available everywhere in every house. So let me show you the materials that you must have with you today for conducting our session. Firstly, you should have some katoris or cups or glasses. What kind does not matter. Of two kinds. See, katoris like this and katoris like this. Secondly, you should have some seeds like this. Now these are rajma seeds, but you can have imli seeds, you can have chickpeas, seeds of a certain kind, or even stones, small stones, about 20 of them. You should have with you a couple of plates like this, saucers or thalis. And of course, the other things like graph paper, which we will use later, and scissors. So I hope you have got your materials, and now let us start our session today. Algebra is generally thought to be a very difficult and a very complicated subject. But what we are doing today, I hope, will persuade you to believe that algebra is one of the easiest subjects in mathematics. One of the easiest subjects. The method that we will be using today is a method due to our guru, Professor W.Sawyer. Can we have slide number 2? Professor Sawyer is one of the world's most popular mathematics teachers. He is no more, he passed away in 2008. But his books continue to educate and inspire. And what we will be doing today in algebra is based on his book called Vision in Elementary Mathematics. Next slide, please. Professor Sawyer wrote a book called Vision in Elementary Mathematics. The approach that he developed there was further developed by the Navnirmiti team in the hands-on universal active mathematics pedagogy. Next slide, please. The materials that you will require for the session today for doing algebra are those 5 katoris or glasses, some seeds which I mentioned earlier, some slates or thalis, and a pencil and paper. So now with these materials, let us proceed. We are going to play a game. The name of the game is called Think of a Number. So I request all of you to think of a number, say between 1 and 9. Keep it in your mind. Don't tell me what it is. You can write it down on your piece of paper. Next, double that number. Whatever number you thought of, double it. Done? Okay, next, whatever answer you got, add 3 to the answer. Done? Okay. Everybody added 3? All right. Next, whatever number you had thought of originally, add that to the answer. Whatever number you had thought of originally, add that number to the answer. Done? I see most of you have done it. So let's go to the next. Now, whatever answer you got, divide it by 3. Whatever answer you got, divided by 3. Divide by 3. Okay. Next, now you subtract, take away, subtract the number that you thought of originally from the answer. And I can read your mind. Look at the camera so that I can read your mind. I can read your mind and I can tell you that the answer that you got is the number 1. Is that correct? Gyanjyoti, you got number 1. Nandita, you got number 1.
Yes. Yes.
And what number did you think of?
3.
3. What about you? You also thought of 3. So you're on the same wavelength. What are the numbers? Did everybody get 1? Did everybody get number 1 as the answer?
Yes.
Okay. Atharva, what number did you think of?
Yes.
9.
Yes.
9.
9. So Atharva thought of number 9. Here, Nandita and Gyanjyoti thought of number 3. But at the end, everybody
Yes,
got the
sir.
number 1
I got
as
the
the
number
answer.
1.
Yes, sir.
Sir, I got 1.
So why
Yes,
is it
sir. I got 1.
that no matter what number you thought of,
Yes, sir.
everybody
3. Yes, sir. I also got 1.
everybody
Yes,
got
sir. I
1.
also got
Somebody
1.
thought of 3.
1.
Somebody thought of 3 and came to 1. Somebody thought of
Sir, I
9,
got
came to
1.
1.
Sir, I got 3.
Sir, I got 1.
Thank you. Thank you. So now let's understand why did everybody. Right. Now let's go to the next slide. Slide number 7. Let's understand what I was doing. How did I do it? Again, let's do a similar problem. But what I'm going to do is I'm going to take this plate and put this katori in this plate. Again, you think of a number between 1 to 9, a different number. Are you done? I took that number and put it inside this katori. Okay? Next, double that number. So what I do is I double whatever is in this katori. I now have 2 katoris. Each katori has the same number in it. Next, add 3 to the answer. So while you are adding it with pencil and paper, I am adding 3 rajma beans in my plate. Okay? Add my original number. So what do? I add 1 more katori. So now I have 3 katoris and 3 beans in my plate. Next, we divide it by 3. Make 3 equal parts. So when I divide 3 katoris and 3 beans by 3, I end up with 1 katori and 1 bean. Next, finally, if you remember, we said take away the original number. So I take away the original number, and what I'm left with is just 1 being in my plate. And that is why we had only 1 at the end of all the calculations. So no matter what I put in the katori to start with, at the end of the exercise, I have only 1 bean, and that is why we ended up with 1. Okay. It did not have to be a number between 1 and 9. Could have been any number, 1,000, million. Okay, let's proceed. I'll take some questions later. The question: explain why 3 should be inside the cup, not outside. I think you will understand what we are doing when we do the next example. Let's go to the next example. Next slide. And you have to do it with cups and beans. In your thalis. So please, everybody, get your beans, your katoris, and your thalis. And when I'm giving you the problem, you do it with katoris and beans. Let's start. Think of a number. So what do? You take the katori and keep it in your plate. 1 katori. Okay, next. Add 3 to it. Right. So we took a number and we added 1, 2, 3. Whatever you have as the answer, double it. Okay, so please show what you have in your plate, Nandita and Gyanjyoti. You have 2 katoris and 6 beans, right? So now let's come back to what I'm doing. Can you see what I'm doing? We had 1 katori and 3 beans. So I double it. I have 2 katoris and 3 more beans. So like Gyanjyoti and Nandita and everybody else, I hope, you have now in your thali, in your plate, 2 katoris and 6 beans. Add your original number. Just get what they're doing. Can we have what Nandita and Gyanjyoti have done? Now the next instruction is divide by 3. Gyanjyoti and Nandita, divide by 3. Whatever you have in your thali, divide it by 3. 3 equal parts. No, the answer is in the answer. What Gyanjyoti has done is to make 3 equal parts, but all the 3 parts are in the thali. The answer is just 1 part. So 2 parts have to go outside the thali and keep just 1 part in the thali. Secondly, those beans were not in the katori. To begin with, the beans were not in the katori. What is in the katori is a number that you have thought of, right? So now the answer after dividing by 3 is 1 katori and 2 beans. Do all of you have 1 katori and 2 two beans? Can we get the responses of the participants?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
All right. Let's come back to the slideshow. Now, the last step is to subtract the number that you thought of, the original number. And everybody is left with the number. Everybody got the number 2 as the answer? When you subtract the original number, what you are left with in the thali is the number 2. Is that what you got? Okay, let us proceed now. Next slide. So what we are doing is keeping a hisab, keeping an account with katoris and beans. And just like we can do hisab with beans, we can also do hisab with katoris. Katori is an unknown number. Beans are a known number. But the way we can keep an account with known numbers, we can also keep an account in the same way with unknown numbers, with katoris. This is the method which W.Sawyer introduces in his book Vision in Elementary Mathematics. This katori, or a pouch or a cup into which you keep your unknown number, that is what is called a variable. In your textbook, it is called a variable. You can keep account of the katoris and the beans, and that is all what algebra is all about. And that is why I said in the beginning that algebra is a very easy subject. And we will see as we go further how easy it is when we do it the way Professor W. Sawyer has told us. Okay. There is a request to repeat the sequence, which I will do here again, but I will do it myself. So let's go back to the previous slide. Okay. I'm going to repeat what we had done earlier. Think of a number. I put a katori in my plate. I am repeating what we had just done. Okay. Right. So think of a number. Add 3 to it. Double this. So 1 katori and 3 beans, I double it. What do I get? 2 katoris and 3 more beans, that is 2 katoris and 6 beans. Add the original number. So now I have 3 katoris and 6 beans. Divide into 3 equal parts. Divide by 3. So when I divide by 3, the answer is 1 katori and 2 beans. And finally, subtract the number that you thought of initially. So I remove the number which I thought of initially, and I'm left with 2 beans as my answer. Can we go forward? So I was summarizing what we have done by saying that we can keep hisab with katoris and beans same way. The hisab of the katoris is our hisab of the unknown number, and the hisab of the beans is a hisab of the known number. But the way of accounting is the same. And we will understand this better as we go forward. We can add and subtract beans, and we can add and subtract katoris. We can multiply the number of beans, and we can multiply the number of katoris. We can divide 4 katoris into 2 equal parts to get 2 katoris. We can divide 6 beans into equal parts to get 3 beans. Beans and katoris behave in the same way. And that is all that algebra is all about. This is the insight that Professor W.Sawyer in his book, Vision in Elementary Mathematics. And now let's take that forward. Okay, next slide. Let's draw pictures. So first we think of a number between 1 and 9. Go ahead. So we have the pouch. That pouch is the katori. We are drawing a pouch here because that is what Professor Sawyer drawn in his book, Vision in Elementary Mathematics. So think of a number between 1 and 9. There is that pouch. And we can also write next to it the number x. This x is just a picture of the upper part of the pouch. It looks like an x. If I take a pouch, a pishui, and I tie it, and then I cut off the shendi, so that x is the shendi of the pishui. Okay, think of it as a pishui or a shendi of the pishui. Those participants, it is just the top which we have cut out and we have written as x. Now we add 3 to it, so we have 1 pouch plus 3, and we have that picture. And here we write it as x plus 3. X was to double it, so we have 2 pouches and 6 beans, and we write it as x plus 6. Then we add the original number, so we have 3 pouches plus 6 beans. So that is x plus x, which we can write as 3 pouches or 3 x's. So we have 3x plus 6. Now when I divide these 3 pouches and 6 beans into 3 equal parts, then one part is just 1 pouch and 2 beans. That is x plus 2. And then finally, I subtract the number that I thought of, which is I remove that pouch, I remove that x, and I'm left with 2. So what we now understand is that x in algebra is the katori. It is the pouch. It is the glass. It is the cup into which you keep your unknown number. Now, I am going to give you some problems using the language of x, and you have to show that using katoris and beans. We have different languages of saying the same thing. I can use the language of katoris and beans. I can use the language of pictures, drawing pouches and dots, or I can use the language of letters and numerals, writing x and the numeral. All 3 languages represent the same thing. It could be katoris and beans, it could be pictures, or it could be alphabets and numerals. Now I'm going to give you the problem in alphabets and numerals, and you have to make it using katoris and beans. Okay. Next slide. Think of a number. So please put that in your thali. Next. Add the same number to itself or double that. So what do you have in your thalis? 2 katoris. Right? Next. Make your thali empty. Now put in your thali x plus 2. Can you show the beans in the camera? X plus 2. Okay, next. Keep your thali empty. Show me 3x. You've got 3 katoris in your thali. Now show me 3x plus 5. So what do you have in your thali?
3x plus 5.
So what do you have in your plate? Gyanjyoti?
3x means katori plus 5 beans.
So you have 3 katoris and 5 beans, or 3x plus 5. Right. Next, aha. Now the problem is to show x plus y. So x is one unknown number and y is another unknown number. For that, you use different katoris. So that is x plus y. But you have some beans also. So please remove the beans. That is
X plus y.
x plus y. Okay. Next, just hold it. Just hold it. Okay, let us repeat the exercise. We can use the presentation a little later. Let's focus back on what Nandita and Gyanjyoti are doing. Okay? Can we have on the screen what they are doing? All right. Let's get back on the screen to what Nandita and Gyanjyoti. Please keep your thalis empty. I'm giving you a problem, and you have to make it. X plus 2. Can we have it here on the screen? What they're doing? Okay. Just take the camera a little bit back so that we can see what Nandita is doing with the hands. Okay. Fine. Let's now make 2x plus 5. In your katori, everybody, all the participants, keep 2x plus 5. So you have 2 katoris and 5 beans. Now I'm write on the board something, and you have to show that, you have to make that in your thalis. So can I have the camera on the board, please? Can we have that in the, fine. So I have written 2x plus 5 minus 5. Can we see what Nandita and Jyanjyoti have done? Can you tell us what is there in your thali now?
2x. 2x.
2x. You have removed the 5 beans. Okay? Now keep the 5 beans back again. What do we have in your plate?
2x plus 5.
2x plus 5. Can I have the camera back on the board? Now the problem is 2x plus 5 minus x. And what answer do we get?
X plus 5.
X plus 5.
X plus 5. Right? all the participants, do you have x plus 5 in your thalis? Please unmute and tell us what you have in your thali.
X
X
plus
plus
5.
5.
X
X
plus
plus 5.
5.
X plus 5.
X plus
X
5.
plus 5, sir.
X plus 5. X plus 5.
Keep x plus 5 in your thali and look at the board, and I'm going to give you a problem which you have to make in your thali. You have x. So the problem is now x plus 5 plus 2x. What answer do you get?
3x plus 5.
3x plus 5. Does everybody get 3x plus 5? Has everybody done it? And does everybody get 3x plus 5? Please unmute and tell me what you've done. What answer you get?
3x plus 5, sir.
3x plus 5.
3x plus 5.
So I think everybody gets 3x plus 5. Are we ready to go ahead? Now I'm going to give you a problem, which is a problem with two unknowns. So make in your thali the following number. X plus y plus 3. And now add So what do you have in your thali? Nandita, can you tell us?
2x plus y plus 5.
What do you have in your thali?
2x plus y plus 5.
Yeah, but you in your thali you have katoris and beans. Huh?
Yes.
So what do you have in your thali?
3 katoris and 5 beans.
But the katoris are not the same.
No.
So you have 2 x katoris,
And 1 y katori.
1 y katori, and how many beans?
5.
And 5 beans, right? So as we can see, it is very easy to keep the hisab of x, y, and numbers. And that is all that algebra is all about. Are we ready to go ahead? Now, I'm going to give everybody a test. And everybody who passes this test can be very good at mathematics. Because in this test, the whole of mathematics is represented. And this is a test which can be given to a 6-year-old child or even a 5-year-old child. Are you ready for the test? Okay, please put the camera on my hands. How much is this? 2. And in this hand, how much is this? 3. Now here is the test. How much here? 5. So everybody who got 5 as the answer has passed the test. Now I'm going to give the next test, which is slightly more difficult, but not very much more difficult. How much is this? 5. Right? How much in this hand? 2. How much in this hand?
3.
3. Everybody who got the answer 3, let's see if it is correct. Yes, it is correct. Everybody who got 3 as the answer has passed this test. But now, you have to write this in algebra. So this is the unknown number. We started out with 5. And now in this hand I have 2. In this I have the unknown number. So please write this in alphabets and numerals. Gyanjyoti and Nandita and all the participants all over India, wherever you are, please write this using alphabets and numerals. And now, Gyanjyoti, will you tell us what you wrote on a piece of paper? Just take the mic in your hand. Spotlight on Gyanjyoti. What did you write?
2 plus x is equal to 5.
2 plus x is equal to 5. Nandita, what did you write?
Same.
Same thing. So, as you can see, the problem that the 6-year-old child was solving was a problem in algebra. Do you agree?
Yes.
And all of you who got 3 as the answer, you were solving a problem in algebra. The problem is, I'm going to write that down, the same thing that Gyan Jyoti and Nandita wrote on their piece of paper. And I'm sure that all of you, hundreds of participants, have also written the same thing on your piece of paper. I'm going to write the algebra of this simple problem, which is something that a class 1 student can solve. Because you have solved it, you are going to be good at mathematics. Everybody who can solve this problem can be good at algebra, because this is just the start of algebra. Let me write the algebraic problem on the board.
Hello, yeah, all the participants. I'm sharing a feedback form link, so you can kindly take some time, push kind of a and fill the feedback form.
I'm writing that on the board. This is one way. It could be x plus 2 is equal to 5. That is another way of writing it. And we know that the solution of this, the answer is x is equal to 3. If x plus 2 is equal to 5, then x is equal to 3. Now, we are going to solve some more equations by setting them up. I'm going to set up an equation here in front of me. Yeah. There is a question, a doubt expressed. Yeah. Come.
Yes,
Sanat. Sanat, what is your question?
Sir, do we have to write the number on the graph paper?
Do we have to write the number on the graph paper?
Yes, sir.
No, you don't need graph paper. Write it on any piece of paper.
Okay, sir.
Okay. Now I'm going to set up some more equations. So if 2 katoris is equal to 6, what is 1 katori? So I divided into 2 equal parts, and I know that 1 katori then is equal to 3. Now write this using x. How will you write it? How will you write this problem? What did you write, Gyan Jyoti?
2x is equal to 6.
2x is equal to 6. And the solution is x is equal to
3.
If 2x is equal to 6, then x is equal to 3. Right? We are solving that equation. Now let us set up a new equation. Equation 3x plus 2 is equal to 8. So here I have 3 katoris plus 2 is equal to 8. So how much is there in the katori? 2. How did you do it? Mentally, right? You just guessed. Just guessed that. Okay. Nandita, can you tell us how you did it?
8 minus
Just a minute.
8 minus 2 is 6. And
What did you do?
8 minus 2 is 6. And 6 divided by 3 is 2. So x is equal to 2.
So first, you took away 2 from each side, and you got 3 katoris
And
is equal to 6.
6.
So 3 katoris in this plate. Let me do it here. I take away I had 3 katoris and 2 beans. This plate is a little small. I'll just keep it here. 3 katoris and 2 beans is equal to 8. And I want to find out, for this to be equal, how much has to be there in each katori. So first I take away 2 from this plate and 2 from this plate. So they are still equal. Then I divide this into 3 parts, and I divide this into 3 equal parts. So each part is what I keep in the plates, and I have katori has 2 beans in it. So x is equal to 2 is the solution of 3x plus 2 is equal to 8. Are we ready to go forward? I will give you a few problems again, and you have to make those in your thali. Do it with katoris. So please take your thali. I'm going to ask the question, x plus 3 plus 5. Can we have the camera on what Nandita and Gyanjyoti are doing. The problem is x plus 3 plus 5. Gyanjyoti, take the mic. What is the answer?
X plus 3 is equal to 5.
What is the answer?
8.
What about x?
3.
X plus 3 plus 5. What do you have in your thali?
X 1 means katori plus 3 is equal to 5.
So total,
Mm,
look at your thali. What do you have in the thali? 1 katori and how many beans?
8.
So that is,
1 katori is equal to 8.
it's not equal to 8. This is not an equation. I have not given you an equation. I'm just asking you, what is in your katori? Say it in x and numbers. Katori is x. So that is, you have 1 katori and how many beans?
8.
Yeah, so that is x plus 8. Okay. Let's just do a things so that it is clear. Just keep the mic with you, Gyanjyoti. Put 2 katoris in your plate. And 8 beans. How will you say that in X language? That is?
2x plus 8.
Just say that in the mic.
2x plus 8.
2x plus 8. Remove 1x. What do you have?
1x is equal to 8.
Not equal to 8.
Sorry, plus 8.
1x plus 8. What is in the katori is 1x plus 8. When it is equal to something, that is an equation. But now that is not equal to something. Keep the mic with. Okay. So now you have x plus 8 in your katori. Remove 1. What is the answer?
1x is plus 7.
So I can say x plus 8 minus 1 is equal to
1x plus 7.
1x plus 7. Remove 5. What do you have in your plate?
1x is plus 2.
1x plus 2. So we started out with 1x plus
8.
1x plus 7. No?
1x plus 7.
1x plus 7. We removed
5.
5. And we ended up with
1x plus 2.
1x plus 2. So I can write that now on the board. Can I have the camera on the board? What Gyanjyoti did, I'm going to write on the board. She had x plus 7, 1 katori and 7 beans. And we removed
5.
5. X plus 7 minus 5. And what was remaining was 2. And I'm going to give it to you in X language. You have to make it in Katori language. Okay? And then finally, tell me the answer, both in Katori language and in X language. So please watch what Nandita is doing. I'm giving her a problem in X language. She is making it in Katori language, but she will give me the answer in both Katori language and X language. Okay? 2x plus 4. Plus 3. What is the answer?
2x plus 7, or we can say that 2 katoris and 7 beans.
Right. You have given me the answer in both X language and Katori language. Now from that, remove x plus 2. What is your answer?
X plus 5, or 1 katori and 5 beans.
The answer is x plus 5 or 1
katori
Katori,
and 5 beans.
5 beans. Now the problem was 2x plus 7 minus x plus 2. Right? From 2x, I'm going to write it here on the board. Problem was 2x plus 7. This is what she had in the Katori. Minus x plus 2. Take away x plus 2. Right? And the answer was, after I take away x plus 2 from 2x plus 7, I'm left with x plus 5. 1 Katori beans. So now, what we are doing is adding and subtracting algebraic expressions. 2x plus 7 is an algebraic expression. X is another algebraic expression. And I'm subtracting one expression from another expression. And the answer is a third expression, x plus 5. That's all what algebra is all about. Adding and subtracting beans and katoris. If we know to add and subtract katoris and beans, we know how to subtract x and known numbers, unknown numbers and known numbers. Any questions from the participants? Okay, Asmi, can you ask your question? Asmi has raised a hand. Can you ask your question, Asmi?
No question.
सर तुमचा आवाज खरखर येतो नीट ऐकू येत नाही.
Yes, sir.
So no doubt.
No doubts. Is it
Sir,
clear?
no doubt.
No doubt.
Is it clear?
Yes sir.
Yes, sir.
Sir.
If anybody has any doubts or any question or any comment, please
No,
ask.
sir.
No doubt.
No
No,
sir.
sir. No. Was it?
No, sir.
Okay.
Aryavane.
Now I'm going to ask some questions by making something in my thali, and you have to tell me the answer in X language.
Okay.
Okay, I'm make an expression in my thali, and you have to give me the answer in X language. Let me take a big thali, slightly bigger thali. My thali. Okay, I have a big plate. Right, good. What is this in X language? What is this in X language? Please raise your hand and answer. Who has raised their hand?
2x.
2x.
Karthik.
2x.
2x. 2x.
2x.
Dhyanjyoti, what is
2x.
2x?
2x.
Okay, everybody got
2x.
2x. All right. Now the
2x.
next problem. Next problem.
Okay.
Okay.
X plus 5.
X plus 5.
X plus 5. Everybody got X plus 5. All right. Now a slightly more difficult problem. I'm keeping this X plus 5 in the plate and I'm adding another unknown number. This is one unknown number, X, 5, which is a known number, and I'm adding what is this? Nandita? Tell me
2x plus y plus 5.
2x plus y, 2x plus y plus 5. Everybody has got that? Any questions?
No, sir. No.
This is 2x plus y plus 5. All right. Now I'm going to set up an equation and you have to write the equation in X and Y language. I'm going to set it up here on the table. Can I have one more plate, big plate like this? So please write this as an equation on your piece of paper. Gyanjyoti, you can stand up and look. What have you written, Gyanjyoti?
2x plus 3 is equal to 13.
13. Nandita, you've written the same thing? 2x plus 3 is equal to 13. So if 2x plus 3 is equal to 13, I want to find out how much there is in each katori. Is there in each katori if both sides are equal? Nandita, what do you get?
5.
5. Can you tell us how you did it?
I subtracted 3 from 13 and got 10 and divided 10 by 2. So 5, x is equal to 5.
Right. Why did you divide by 2?
Because x is multiplied by 2. So that's why.
Because there are two x's here. There are two x's here. So to get what is in one katori, I have to divide by 2 katoris by 2 to get 1 katori. Is that clear?
Yes.
So now we know how to solve simple equations. And let us go forward now. We are going to learn how to write x in a different language. First, we saw how to write x in the language of katoris. Now, we are going to learn a different language for showing X. And that is the language of graph paper. Can we have, I'm just going to show it to you. We're not going to do it actually. I'll give you the problems as homework problems to do. I'm just going to show you how we can do it using graph paper. Can we have the graph paper here on the board? I'm just setting up the graph paper on the board, and I'll pose you the problem. Now we have graph paper here on the board. Can we have slide number 18? X equal to 3 centimeters, and we draw X. So I draw this as X, 3 centimeters. And the problem now is to draw X plus X. Use graph paper. Draw X plus X. Draw 2X. If X is equal to 3 centimeters, draw X plus X. Okay, you've drawn X plus X.
Yes.
Next problem is draw
Yes, sir.
3X. So I hope all of you drew this. X plus X.
Yes, sir.
Next problem is draw 3X. Draw 3X.
Okay.
And please see if you have done what I am doing here. This is X, 1X, 2X, 3X. 3X, which is also X plus X plus X. Okay? So adding Katoris is one way of adding X's. I can also add X's by drawing a line to represent X and taking 3 times that line for 3X. X plus X plus X. Let's go to the next activity. I'm now going to take 2 unknown numbers. I'm taking now A, which is 2 centimeters, and I'm taking B, which is 3 centimeters. So please take on your graph paper. You can draw freehand, you don't have to use a scale. Take A as 2 centimeters and B as 3 centimeters. And now the problem that you have to solve is, if this is A and this is B, show A plus B. Do that on your graph paper. Okay? Can we see what Nandita and Gyan Jyoti have done? That is A plus B. And the last thing that we're going to do today, which is going to be the that we will do in the next session. The last activity is to draw A multiplied by B. Here we showed A plus B. How will we show A multiplied by B? I'm not going to tell you the answer. Think about it. That is going to be our first activity in the next session. How do we show A multiplied by B? Think about it. Now, before we conclude, the next slide will have the homework problem that you have to solve for yourself. You can send your results, your solutions by email. We began by discussing about Professor W.Sawyer and his very simple way of introducing how to add and subtract unknown numbers. We played a game and we saw that we can represent an unknown number by katoris or by cups or by glasses. And then we can add and subtract katoris in the same way that we add and subtract seeds. And so we saw that we can make expressions because those katoris or the pouches are just unknown numbers. We can also call them as X or Y or A or B, and we can write expressions which is the same as making in your a combination of katoris and beans. And we can keep the hisab of katoris and beans just like we add and subtract teams. Finally, we saw how we can set up an equation, like for example, what I have set up here, 2x plus 3 is equal to 13. And we can solve it. So we learned how to solve simple equations. And then finally, we saw how to express x as a line on graph paper. If we write x as a line on graph paper, we know how to write x plus x plus x plus x. Finally, a problem. If we have a and b, how do we represent a multiplied by b? That is what you have to think about. And that is what we will be discussing at the beginning of our next session. So this is our introduction to algebra by the way of Professor W.Sawyer. Before the next session, I want you to prepare this. Take a graph paper like this, take a piece of cardboard or card paper like this, and stick the graph paper, cardboard, and have it ready, because we will be cutting the graph paper which is pasted on card paper the next time. If you don't have card paper, you can paste the graph paper on any thick paper so that it is a little stiff, because in the next session, we will be using this graph paper which is pasted on cardboard for cutting and making shapes. The final slide, can we have the final slide?
Thank you, sir.
Also,
Thank you, sir.
Thank you, sir.
and
Thank you all the participants.